Okay, so this video today is meant to accompany the lesson reaction patterns. Now these are all things that we did in the lab, but there's so much it'd kind of be hard to reset up, so I'm making this video so you can see the reactions and be able to do this assignment on your own time. So once you download those slides, on the first slide you go through and I want you to list some chemical reactions that you're familiar with. You can see over my shoulder some of them that we talked about in class, like baking a cake, or baking soda and vinegar, or making slime, okay, things like that. You also need to record how do we know that those are examples of chemical reactions. Okay. On slide 2, it lists all of the different experiments that we did in class that I'm going to show you here. While I'm doing these, you'll want to go through on slide 3 and be listing the name of the reaction, what are the properties beforehand, and then what are the properties after the reaction. Okay? And then on the last slide, you once again reiterate the definition of a chemical reaction, which we've been over a couple times before, and then list any patterns, things that we saw happen multiple times. Okay? So the first reaction I'm going to do today is that classic baking soda and vinegar. So here in a flask I have some baking soda. Okay, properties is that it's a white powder. Okay, it's non-flammable. Okay, things like that. Then I have 4 milliliters of vinegar. Vinegar is a liquid. Okay, together as they mix, as I'm sure you are familiar with, they produce gas bubbles as well. So they're producing a brand new little gas bubbles there. Okay, very simple. So record those properties. Then the next one is another one you've done, I'd assume, which is taking a piece of paper and just burning a piece of paper. So I have a little square of paper here. Okay, list the properties of paper previous to it burning, and then like this. See it burning there. Okay, in that tray. And then, though not all of it burnt, that's okay. Don't need it all to be able to see the properties that are going on there. And realize that the smoke is also one of the reactants from this reaction, and that it also assists, or should be considered with the experiment as some of the final products. Okay. Then, next one is Alka-Seltzer and water. So I have a little bitty flask here and half of an Alka-Seltzer tablet. And what I'm going to do is I'm going to break this up a little bit more so it'll fit better into this little flask. Okay. Do this here in the pie tin. And then I'm going to try and put this bag over the top so then we can get an idea, this balloon, how much gas is being produced by this reaction. Okay? And you can see once again, this is making bubbles or making a gas that was not here originally. Okay? Wasn't here beforehand. So I'll just kind of set that off to the side. Okay? The next one's burning alcohol. Okay? This is one where I really ought to be safe and make sure I have some safety glasses on. Okay? So I'm going to burn 1 milliliter of alcohol. Okay. Put that in there. Think about the properties of alcohol. How does it smell? How does it feel? Okay. Things like that. Like that. Okay. And this will actually just burn itself out, right? But it's another one where we're still seeing a flame. Flames are important with chemical reactions because they show that energy is being released. That energy is both heat and light is being released through that chemical reaction. Okay, so no more flame, but actually there is some residue here. It doesn't smell like alcohol, and if I try and burn it, that remaining residue is not flammable. I can't get that to burn. So that's a change in property. Okay. The next one I want to do, and I'm just flying through these, so if you need to be pausing this video so you can do this on your own and keep up, then please do so. This next one is using the chemical bromethyl blue that we looked at with the dry ice experiment. Okay, it's a blue liquid here. And then in this beaker here, I have club soda, which is just carbonated water, right? So I'm going to add some club soda there, and you see that it turns yellow, okay? So we have a change in color that accompanies that experiment there, okay? Okay, next, what I'm going to do is I'm going to light this candle, and I'm going to use this candle to try and roast a marshmallow I have here on a fork, okay? You can actually see right away we're kind of getting some black marks here on the marshmallow. Okay, you've hopefully had a chance to roast a marshmallow before on a campfire or off of your stove. Okay, some people roast a marshmallow on the stove, and you can see it's getting a change in color, change in smell. It gets that toasted marshmallow sort of smell. Also gets a change in texture, okay, so forth. Okay. Okay, and then we have two more, which are just before and afters. We have glow sticks. So this is a glow stick that's been activated. If I look at it, I can see that it glows. This is one that hasn't been activated. You can tell there's a slight color change in them, and that this one emits light, this one does not. Okay, once again, thinking about that energy and how it's involved. And then the last one are some foot warmers, okay, hand or foot warmers. This is a package that has not been activated, and these are two that have been activated, and so they're giving off heat as they react with the oxygen around them, okay? So consider all of these. That's all of them. Make sure you list the name of the reaction, which if you didn't catch that, it's on slide 2, goes through all 8 names. Then what are the properties before the reaction, what are the properties after the reaction, and then lastly, fill out the definition, and then look for those patterns. And as you look for those patterns there on the last slide, be thinking about energy and how energy is involved. Some things absorb energy, some things release energy, some things will do both. And that's true for both chemical and physical changes, but it's something that is worth thinking about, okay? Email me, as always, if you have any questions with the assignment.